Welcome to aminacademy.com. In vector space, let us discuss about vectors in R power n and C power n and spatial vectors. Normally, vectors are useful in many branches of science. Here, we will discuss about vector in physics. A quantity that has both magnitude and direction, it's called a vector. It is typically represented by an arrow whose direction is same as that of the quantity and whose length is proportional to the quantity's magnitude. Although the vector has magnitude and direction, it should not have position. Here, suppose this is a vector AB. Here, vector in maths are objects which have both magnitude and direction. The magnitude defines the size of vectors. It is represented by a line with an arrow, where the length of the line is the magnitude of the vector and the arrow shows the direction. That also it is represented in three-dimensional geometry also. Now, many physical quantities such as temperature, speed possess only magnitude. That means speed can have any direction, but its magnitude is considered only. The quantities can be represented by real numbers and are called scalars. On the other hand, there are also quantities such as force and velocity that possess both magnitude and direction. These quantities, which can be represented by arrows having appropriate length and direction and emanating from some given reference point O, are called vectors. That means that vector should start from initial point and goes regarding its magnitude with its direction. Now we assume that we are familiar with the space R cube, where all of the points in space are represented by ordered triples of real numbers. R cube means three-dimensional spatial vectors. Suppose the origin of the axis in R cube is chosen as the reference point O for the vectors discussed above. Then every vector is uniquely determined by the coordinate of its endpoints and vice versa. There are two important operations, vector addition and scalar multiplication, associated with vectors in physics. The definition of this operation and the relationship between these operations and the endpoints of the vector are called as follows. Here, vector addition is represented in parallelogram law. Scalar multiplication is extended the line length. Now we will discuss about vectors in R power n. Here, look at here. Suppose the vector u in R power n in vector space R2. So R power n here. U equal, vector U equal, you can say the points A1, A2, A3, A4 up to AN. You call it point or a vector. This is called a point or a vector. Two vectors u and v are equal if we can say vector u equal to vector v. Here, look at here. Here the points are 1, 2, 3 and second points are 3, 1, 2. Here these two vectors contain same numbers, but order is not same. These vectors are not equal because this 1, 2, 3 means x, suppose x direction, y direction, z direction. Here x direction is 3, y direction is 1, z direction is 2. The order is changed, so it's not equal. These vectors are not equal because this order is changed. Here, look at these vectors. Here 2 minus 4 is in R squared space because this is a two-dimensional. 0, 0, 0, it is R cube space but 0 vectors, no magnitude. Here 4, 3 minus 2 is in R cube vector having some magnitudes. Now for this, when suppose this vector 2, 5, for this we can say x plus y equal two plus y x plus y equal to 2 plus y. That is, you can say x plus y equal to 7. Like you can say y minus x, you can say 5 minus 2 equal 3. Like this you can represent in xy plane also. That means here by definition the equality of vectors we can read like that, means two vectors are equal here if all numbers and positions are same, but here even the numbers are same is not equal vectors. Here we can see vectors can be represented in column vectors also. Like here 1, 2, we can say 5, 3, 2. Like we can represent vectors in column. It is R2 vector, this is R cube vector. Here in general we can say vector addition. Look at here. Suppose U equal A1, A2, A3, AN. Then B, B1, B2, B3, like Bn. Then you can say addition, subtraction, you can do first. U plus B is of course this A1 plus B1 A2 plus B2, like A3 plus B3, AN plus BN. Like subtraction also same procedure. Then scalar product K U, that is K is some scalar, you can say, right, it is KA1, KA2, KA3, KAN. Like in subtraction also, right? Then minus over here, minus 1 into U, of course it is minus U. These are simple cases, and we can say U minus V can be written as U plus or minus V. Here, suppose we can write some column additions. Here, U is in column vectors 2, 5, 3, 2, 5, 3, V equal 5, 4, 6. So that is, we can say, suppose we have to define 2U plus 5V is nothing but this U is multiplied here 2 and V is multiplied with 5 and added. Here 2 into 2 is 4, 4 plus 25 is, because 5 into 4 plus 25 is 29. Then next 5 2s are 10 and 5 4s are 20, totally 30. Then here 2 3s are 6 and 5 6 are 30. 2 3s are 6, 36 here. Like we can scalar multiplication with vectors and add and subtraction we can do. Next, dot or inner product. Dot, or it's called inner product. Here, suppose U equal 1, 2, 3, V equal 4 minus 2, 3. Here, how to find U dot V? U dot V is first term with first term of V is multiplied 1 into 4 plus 2 into minus 2 plus 3 into 3. Here it is equal 4 minus 4 plus 9, which is equal to 9. That is, dot product of U is 9. Like this we can do dot product or inner product of two vectors, three vectors, like. Now next is length of vectors. Length. Here consider here is same that length of this UV is u dot v square root is equal first length of u you can find equal 1 square, 2 square, 3 square. Square plus 2 square plus 3 square. 1 plus 4 plus 9. That is 30 square root. Like you can find here, you can find the length of linear vectors by using square root of the squares of each values. Like this, here consider two axioms or theorem here. In order for u modulus of u dot v, that is length of u dot v is lesser or equal to the integral length of u into length of v, and u plus v also length of u plus v is lesser or equal length of u plus length of v. Now angle between two vectors is, suppose, cos theta, that is between two vectors u and v is u dot v over modulus of u into modulus of v. From this we can find angle between these two vectors. Like this we can do many problems in terms of dot product, addition and subtraction of vectors in vector space. If you have that, please subscribe our YouTube channel.